Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what we went through in week 9. We just looked at right-angled trigonometry. So there are 3 trigonometric ratios you need to know: sine, cos, and tan. The acronym SOHCAHTOA helps you determine which one you use when. So in a right-angled triangle, we label one of the other angles other than the 90-degree angle here theta. So opposite is the shorter side facing theta, adjacent is the shorter side touching theta, and the hypotenuse is always the longer side, and it's always opposite or facing the right angle. So you use sine when the question involves opposite and hypotenuse, cos when it involves adjacent and hypotenuse, and you use tan when it involves opposite and adjacent. So let's firstly look at using trigonometry to find unknown sides and angles in right-angled triangles. So we'll look at these 3 examples down here, starting with the one in blue. So we want to find x, which is an unknown side. So our first step is to determine which ratio we're going to use. So compared to this 32-degree angle here, x is the opposite, it's the shorter side facing it, and 7 is the hypotenuse, opposite the right angle. So opposite and hypotenuse, we use sine. So we have sine of angle equals opposite over hypotenuse, and we solve that for x. So in the next one here, compared to the 40-degree angle, we have the opposite and adjacent. So opposite adjacent, we use tan. So when we're finding sides, sometimes the thing you want to find is on top, sometimes it's on the bottom. So when the thing you want to find is on top, you times, as we did here, x is 7 times sine 32. Just put that on our calculator, making sure it's in degrees. And when the thing you want to find is on the bottom, you divide. So this isn't 10 times tan 40, it's 10 divided by tan 40. And again, putting that on our calculator. So in any triangle, note that the shortest side is always opposite the smallest angle. So here, smallest angle is 32 degrees, so x should be smaller than 7, the shortest side. That gives us an indication we did something right. Similarly here, y would be the middle length side. Y would be opposite a 50-degree angle, so the answer I get should be more than tan, which I did. So you use sine, cos, and tan for sides as we did here, but if you're finding an unknown angle, you use sine inverse, cos inverse, or tan inverse. So this question involves the adjacent and hypotenuse, so I would use cos. But because we're finding an angle, I use cos inverse. So we'd simply have that theta is cos inverse of adjacent over hypotenuse, which gives us about 23 degrees to the nearest degree. Once again, I need to make sure my calculator is in degrees. All right, let's look now at some exact values. So we'll look at these 2 special triangles. The first is a right-angled isosceles triangle. Isosceles means 2 shorter sides are the same, meaning these 2 angles will be equal. They'll be 45. So by Pythagoras, if the shorter sides are 1 and 1, the longest side is the square root of 2. We can use this to come up with some exact values. So sine 45 is opposite over hypotenuse. Sine 45 is 1 on root 2. Cos 45 is 1 on root 2, and tan 45 is 1 from this triangle. It turns out if we have a right-angled triangle where the middle angle is double the smallest angle, turns out the hypotenuse is twice as long as the shortest side. So this means by Pythagoras that the middle length side will be root 3, which is like 1.732, and so we can again get some exact values. For example, sine 30 opposite over hypotenuse, sine 30 is half. Tan 60 is opposite over adjacent, root 3 over 1, and so on. So make sure you learn these exact values. They will become very important when we do the unit circle. All right, let's now move on to some applications. So trigonometry can be used to solve real-world problems, particularly those involving bearings or angles of depression and elevation. So let's look at this question here. Angle of elevation to the top of a building, 40 meters from its base, is 54 degrees. How tall is the building? So we should start by drawing a diagram. So we've got our building here, and I'm going to let its height be x. So 40 meters from the base of the building, the angle of elevation is 54 degrees. Now, all trigonometry involves triangles, so we should make this into a triangle. So the angle of elevation is the angle looking up at something, and it's always the angle made with the horizontal. So this here, theta, that is the angle of elevation. The angle of depression is the angle looking down at something. So this would be the angle of depression. I've called them both theta because the angle of depression and angle of elevation are always equal in value, even though they represent slightly different things. So theta here, we were told in the question, is 54 degrees. So that means that the angle of depression is also 54 degrees. So we're going to assume that a building is at right angles to the ground. In that case, we have a right angled triangle, an angle and a side. We can use this to find another side. So we first ask, which ratio am I going to use? Well, compared to this angle, I have the opposite and adjacent. So I'm going to use tan. So it's tan of angle equals opposite over adjacent. And remember, if the thing you want to find is on top, you simply multiply. And that gives us about 55.06. So it's in meters because the question mentioned meters. That's how tall the building is. All right, let's now look at bearings. So bearings are when we assign a number to each direction so that we're unambiguous the direction in which you're traveling. So I gave the example. If you want to fly to Sydney, you have to fly northeast, but northeast could be over here or over here. If we give each direction a number, then there's no ambiguity. Are you going in this direction or this direction? So bearings are an angle made with the north axis always going in the clockwise direction. Due north is 0 degrees, due east 90 degrees, due south 180 degrees, and due west 270 degrees. So let's look at an example here. I travel 80 kilometers east and 120 kilometers south. On what bearing must I travel to return to my original position? So we're going to start by drawing a diagram. If it's a bearings question, you should start with a compass like this. So what I'm going to do is travel 80 kilometers east and 120 kilometers south. So as I said, trigonometry involves triangles, so we're going to make this into a triangle, and of course east and south are 90 degrees, so we have a right-angled triangle. So I have gone here, then here, so I need to know what's the bearing when I start here to go up to there. So to do that, I need to know this angle here. So I have opposite and adjacent, so of course I'm going to use tan. So the angle here, tan inverse of 80 over 120, 33.69 degrees. But that's not the bearing. See, the bearing is the angle made from the north axis going in a clockwise direction. So the bearing is actually this angle here. So I can find that bearing, that angle in green, pretty easily. See, it would be 360 all the way around. So this will just be 360 minus 33.69. And that gives 326.31 degrees true. We usually just put a T there, indicating we're using true bearings. See, that makes sense, because if I've gone east and south, and I've got southeast, I need to go northwest to go back to my starting point. And northwest means the angles between 270 and 360, which I got here. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.